Hello. Hi, everyone. My name's Andrew Gerrand, and I am on the Go team, and I'll just get everyone to introduce ourselves, starting with Robert on the right.
Hi, I'm Robert Griesemer. I'm working on the Go team.
Hi, I'm Rob Pike, and we're all working on the Go team.
I'm David Symonds.
Ian Taylor.
Samir Ajmani.
Brad Fitzpatrick.
And so this is basically just a free-form session about Go. We have a Google Moderator link online, which people watching the live stream can contribute to. I don't have the link handy, so if you want to find it, just search for something. I'm not sure. But good luck. You found the live stream well enough, you should be able to find the link. But otherwise, maybe just a little bit about what's going on recently. Can I get a show of hands who here uses Go regularly? Hey, that's great. Really gratifying to see. So as probably most of you know, we released Go 1.1 earlier this week. That's a really nice milestone for us. So thank you. About a year on from 1.0, and we're pretty happy with the progress so far. It's been really great meeting people over the past few days at I.O., or the past couple of days, hearing about what you guys have been doing, but now we'd really like to turn it over to you and hear your questions and tell you what's going on. Does anybody have anything? Oh, the microphone's here. We might start with a question from the Google moderator.
This is Nigel, also on the Go team, just off the video. Just for the record, the Google moderator link is goo.gl/8 lower s capital G 1 lower h, in case anyone wants to know. Of course, live questions are welcome. We have 2 microphones up, but whilst we're waiting, I'll just go off the top of the moderator. So the first question is from Fulung from South Africa. So D. Vyukov, Dmitry, Minix, Remy, KHR, Keith, Brad Fitz et al. Are doing an awesome job of tearing apart the runtime and the standard library and putting it back together, but faster. Can you discuss your big N ideas, 1 less than N less than 5, for making Go programs go faster for Go 1.2?
I just run things under a profiler and see what's at the top. And a lot of the times lately I've been seeing that we allocate lots of garbage. So I've been trying to get rid of garbage. But it was just something I was doing towards the end when there was nothing else to do. I don't know how long it'll remain a focus, but it's definitely fun. And there's a lot of people focusing on performance now. So, I mean, we can't break APIs, so we can make things faster with the existing APIs.
Well, the tooling can get a lot better. One of the best ways to avoid to make Go programs go faster is to control how much garbage you generate, because the garbage collector, no matter how good we make it, is always going to be potentially a slow spot. The best thing to do is to avoid garbage. So we're worrying about trying to get the compilers to detect more cases where an allocation can be placed on the stack and things like that. The compilers are also doing better inlining and better optimizations. We're also spending a lot of time looking at the runtime. We have a long list of things to do involving improving how the stack is implemented, how the scheduler works, trying to make it work better with maybe using some lock-free algorithms in some parts of the runtime. So the step from Go 1.0 to 1.1 was, depending on your program, anywhere from not much faster to, we've heard stories of people running on big machines with seeing 10x in some cases. But typically like 30, 40%, something like that. And I'm sure we can get another significant speed up for the next round by concentrating on the internals and the tooling and also the APIs. But I want to stress that you can find ways to make your own programs go faster by using the tools that are already available. The profiling tools are very good.
Yeah, it's probably worth mentioning that straight after 1.1, immediately all of the people who've been hacking on the runtime jumped in with a whole lot of more stuff that they've had sitting on their machines, just waiting to mail it out. So there's a lot of activity in that area going on.
Do you have plans to address the whole... So recently there's been some articles about importing source and being able to tag them with versions. Do you plan to address that anytime soon?
Yeah, so maybe I should... Yeah. This has come up a lot because the way GoGet works, we use the import paths to identify the location of repositories and then fetch code automatically, but currently there's no way to version those things. And the idea behind the design of that system was that people would keep their head of their repositories clean and stable. But in practice, it obviously doesn't work like that. And I think there's a lot of space in the greater Go ecosystem to introduce better tooling to make that easier. I've seen some really interesting designs recently for tools that would let you kind of take a snapshot of the state of your workspace and then be able to replicate that state in other places, so working in teams and stuff like that. But I think it's not a design. I think it's not a problem inherent in the design, but rather something that just needs to be finessed more. And it's something that is increasingly been coming to our attention. It's kind of hard for us because working on the core, we don't suffer from that as much. But I can definitely see how it affects other people. It's been hard for us to think about the problem as it's not a problem that we have so much ourselves. But I think it's something that's going to be solved, soon. It definitely has my attention, at least.
On a slightly related note, are there any plans to support, say, compiled Go libraries, like from Go to use other Go libraries, as opposed to everything just being static, binary?
It's something I'd certainly like to see. It's not. I mean, it's a tooling issue entirely to do dynamic linking. We don't have any. Well, first of all, it does work with GCC Go today, but we don't have any immediate plans to make it work in the GC compiler toolchain. But we have all the basic building blocks needed for it, so I hope it'll happen. I think it will.
Thank you.
Hey, first off, I'd just like to say I like the look of Go. It seems like a great language and a good successor to C. One of the things I don't know if it's been considered, but personally I'd love to see it as an option on Android for development. I think it would be a very good fit there. That's not the question though. Like many people who use a bunch of different languages, there's some features I'd love to see in Go, and I wonder if they were considered and if they were decided against for any particular reason. I think the primary one would be more expressions than statements. So the if, the try, various language constructs are statements in Go, which means that you need vars rather than vowels a lot of the time, and you can't use as much immutability. Did you consider making like if an expression, and if you decided against it, why?
I think this is your.
All right. I was trying to fob that one off. The problem with it, I actually really like the idea of expressions as computable things, like if statements and so on. I've even implemented similar functionality in other languages. It didn't really come up in the design. I don't think it was deliberately left out. We were just trying to keep the control flow really clean and simple. The control structures, although at first glance look a lot like C or Java or something like that, they're actually quite a bit simpler. They've been reduced a lot. And I don't think it was, I don't remember consciously saying we want to not do that. It just sort of never came about. And I don't feel the pressure for it. One of the things we did do was dramatically reduce the number of things that from C would be treatable as expressions, like assignments, pre-increment, post-increment, stuff like that. And we made those explicitly statements because that has a very strong effect on the simplicity of the specification. You have much less to write about where things happen, when things happen in the order of evaluation by making those not be expressions. And almost every C program that ever went down badly had a misuse of that property. So just taking it away was a simplification. But as far as making if be an expression, it just never came up. It wasn't a deliberate omission.
I think one of the common questions is probably the question mark colon operator. And I think that was probably deliberately left out. But if were an expression, then other questions come up, and I think the kind of code you would write would start to look a little bit different. And as it is right now, you can more or less say, unless you have function calls, of course, or method calls, if you're an expression, it's kind of essentially an expression that's side effect free. But if you have things like sort of control flowy things in your code, then that might look different. It might be different to reason about those programs. I think it will be a different language.
Okay.
Hey, so going back into performance, I actually wanted to talk about how Go interfaces with CGO, and I noticed that going from Go 103 to 1.1, the performance in terms of interfacing with C Go like improved dramatically. I saw like a huge, almost 30x performance in certain programs that use C Go, which I thought was really freaking awesome actually. But I also saw some random bugs which were not in 103 that were in 1.1. Some seg faults in CLAN, which I kind of still working through. And in general, I just wanted to know if you guys had any like more documentation on how these things are kind of implemented, like how the implementation changed from 103 to 1.1. I took a quick look and everything is very like broad. There's nothing like nitty gritty. I know I could always read the source code, but that's very daunting at times. So I don't know if you guys have like any like white papers or research documents. I don't know.
Specifically for Seago, we did beef up the docs on Seago quite a bit on how it works internally. If you go and look at, you know, golang.org/cmd/Seago, you go down to the bottom, we've added like a couple more pages on what it generates and how it interacts. But there's no white paper on how it all fits together. More documentation is always good.
Yeah,
certainly,
definitely.
no one's going to say otherwise.
I think that documentation is not actually in the web page. I think you have to look at doc.go in the CGO directory. And it's like a comment past the package comment that's quite a long, detailed discussion of the implementation. So that might be illuminating. It was certainly illuminating to me to read.
Okay, cool. Thanks.
Oh, thank you. I asked a question previous session, and they asked me to ask it here, is there any special debugging or anything we should know about with App Engine and Go? Like race, all those tools, race, and can we do like we can run an App Engine app locally on our machine. Can we use all these tools to debug there too?
You can't yet. But it's on our radar, it's coming down the pipeline, we just have to get to it. But yes, coming soon.
We actually want to make Go be the best language for App Engine, and part of that is making the tools for it be really awesome. So you should expect to see some wonderful stuff at some point soon. How's that?
Heather, I was wondering if you could just provide a little bit more insight as to the extent of the use of Go at Google. The description on the Go language site is relatively brief, and it just mentions kind of a couple things like, oh, it's in use at YouTube, and that kind of leaves it at that. This kind of ties into a separate thing that we've had discussions about in the office where we primarily do consulting work for clients, and at times we've thought that Go seemed like a great match for what we wanted to do, but there was discussion about how heavily vested Google was in the language. And I hate to invoke the phrase, but you often hear, nobody ever got fired for choosing Java. And I really want to advocate use of Go, but it's been kind of a bit of a black box as to how certain development on it is in terms of resources being allocated to it. And I think in recent months we've seen a lot of really promising things and a lot of great features coming out. So I'm willing to stand up and make a harder push for it next time, but I'm still curious to hear a little bit about how it's used.
Well, I want to point out that although Google pays our salaries, Go is an open source project completely, right? So, it's a fair question and we'll answer it, but I want to make it clear that it's very different from Java, which was a Sun product that was pushed by a company, had a massive marketing budget. Go is a project that we're allowed to work on as part of working for Google because it helps Google, which I'll talk about in a second. But it is really an open source project. Far more people work on Go outside Google than at Google by orders of magnitude. It's a much, much bigger number. So don't conflate Go and Java that way. I think that's unfair. As far as Go's use internally at Google, there's a number of projects. Brad could probably talk about one in particular that are not as well known, but there's the YouTube thing. Brad talked about download server. There's a tremendous amount of external facing traffic that you don't see as a Go program because it's a Google service, but a lot of bits flow through Google's production clusters serving stuff relevant to users, and the amount is growing rapidly. There's a lot of teams picking it up. There's some key infrastructure that's built in it. We don't talk about it, but we don't talk about the C++ use internally either. Right? It's just not it's internal stuff, but the growth is really highly important and I think strategic. Although that's just me talking, that's not Google talking. Do you want to talk about stuff, Brad?
I was going to talk about the Google download server this year, but I think I'll be talking about it later. But all the Google download server was rewritten from C++ to Go. And about, I don't know, I'm working with 3 or 4 other teams right now that are porting large systems from C++ to Go. Just about every big system at Google generally has a lifetime of a couple years, and when that comes up, time to rewrite it or redesign it, a lot of those teams are now looking, and asking themselves why they're writing it in C++. And a lot of them are picking Go because it's, yeah, I mean, if you guys write Go, you know why. Sometimes you don't really need C++. It just happens that we have, as a historical accident, Google had lots of C++ libraries, so just everyone wrote in C++.
I was recently looking at the numbers, and over the last year and a half, the use of Go at Google has gone up by an order of magnitude. So, that's not, I can't tell you the numbers, but it is going up.
Great, thank you.
So Go on App Engine, unless there's been an announcement recently, is still experimental. And full-text search on App Engine is still experimental, so I'm probably asking a nexus of extremely experimental questions. But there seem to be full-text search doc stubs for Go on App Engine. Is that supported in an experimental sense and just not documented, or is it not even sort of possible to use at this point, and can we get it?
Go being experimental, we don't see it that way. Like our team, to a degree that the stuff that we're putting out, we are standing behind and not going to change randomly and so on. So we're not treating it as an experiment in that sense. It means that when we support APIs, we want to come up with a good API design, one that we're happy to stick behind for years. We do have a full-text search API being worked on, where it's just not quite done yet, but it's coming.
Thank you.
Hi. So a few months ago, I picked up a Chromebook about the time that I rediscovered Go and kind of started playing with both of them and started going through the tour. And one of the things that I kind of realized is that they really fit really well together. Go would be a great platform to be running on top of a Chromebook. And in fact, you might even be able to make a shell out of that and replace Kosh with Gosh. And you have already a really strong metaphor of channels with coroutines or Go routines being the applications that you could actually be launching. And the only thing that's really kind of holding that back, I think, is that there's not really a script interpreter for Go. And I'm wondering if that's even a reasonable idea, or if it's a good idea, or if it's just completely off the wall.
I think we actually had once sort of a partial interpreter that was kind of a prototype, and I know at least of one internal project where somebody wrote a package which you can consider something like a Go script thingy, which allowed you to run, or basically, run a piece of code that you would type in, and it behaved like an interpreter, but it's not quite what you probably want. I think it's a feasible thing. It's just not done and available in a public form that's really usable.
I see it as a great opportunity to bring a lot of developers and engaging with Go and kind of expand the audience. And I don't know, it seems like a pretty decent fit.
I think there's a bunch of questions that need to be answered when you do something like that, because most languages where you have an interpreter have a particular model around that interpreter. Say Lisp or something like that, which is really sort of expression-oriented one after the other one. In Go, you have the concept of a package and things that are simultaneously initialized, etc. So questions like that need to be answered. What does that mean, having an interpreter in that context?
Yeah, just the next question from the moderator, from Dave Cheney. Putting aside the Go 1 guarantee, if there was one thing you could remove from the language, what would it be?
You usually get told to put things in, not take them out. A couple of things. I'm unhappy with some things, but we can't fix them. I was never a fan of the way the ampersand stuff works to take the address of a struct, because it's kind of special casey and bugs me, although I admit it's very nice to use. I think that the whole declaration, the number of ways you can declare something is too large and too messy and needs to be completely rethought, and people get confused by it. So that's something. There's also an unfortunate thing around the difference between a nil value and a nil interface that confuses people a lot, and that probably could use a rethink. Those are things I would take out, but there's certainly things I would change if I were starting over. You probably have a long list.
Not necessarily a long list, but I think the number of declarations of a variable, as Rob mentioned, is something that I think needs to be rethought. There's just too many ways to do the same thing. The colon equal operator that allows you to quote unquote redeclare a variable is very convenient, I admit, but it also introduces a whole bunch of questions, and in the beginning it introduced a whole bunch of bugs that we now sort of circumvent a little bit because the compiler gives you great warnings, but still I actually have to think twice every single time I redeclare a variable that happens to be also a parameter of a function, making sure that I'm really using the same variable again. So this is something that I think we can do better. There's also a few issues with embedding of types in structs that are, I don't know, there's some unresolved issues there. I think that maybe we can do better.
Personally, I think I might drop named result parameters. I think they were a good idea, but I don't think that, I think especially in conjunction with colon equals, I think they've led to a certain degree of confusion. And an idea that Russ suggested, we need the syscall package, but I don't know if we needed to provide the same compatibility guarantee for the syscall package, because it's essentially an interface between the language and the system, and systems change, and we've essentially promised that we're going to be compatible with all future systems, and that's difficult.
I'd remove the complement of the named return values, which is the naked return statement. So if you name your return values and just write return, it'll return whatever those values are. And I see a lot of people getting those wrong, and I don't think it's as much a saving as it looks.
I would change the in range loops when you declare variables. The variable is reused on each iteration of the loop, which has zero actual benefit in real code and can only ever create bugs where you accidentally close over that variable inadvertently and it gets reused in the wrong part of the loop unnecessarily. That was something we should have fixed in Go 1, but didn't. There's a Go vet thing that catches a lot of uses of that now, so that's something.
Okay. I'd to thank you for sort of sticking together the two languages that I used in the 1980s, which was C and Occam, into something so I can actually dig out some more brain cells to figure that out. I got a more modern question though. I just got these Google Glass things, and I'm about to write some code for it. Should I write that in Glass? So should I write Glass code using Go, or should I be off copying all of the examples and doing Java like everyone else is? Whereas anyone else in here have you heard of anyone else trying to do Glass stuff in Go?
Are you talking about the Mirror API?
Yeah.
That should work fine in Go.
Yeah.
The Go client library for it is auto-generated from the same JSON description of the API as everything else.
Right.
And I've reviewed code by some of the Glass team that have written Go code, so they're using it, so I think you should as well.
Yeah, we actually had a bug in the API generator I wrote, and it was actually generating malformed Mirror APIs, and then somebody on the Glass team mailed me a patch to the Go generator, so they've used it at least. And I know Francesc said he wrote a little hello world for his Glass.
I'll probably dive in the next few weeks. Thanks.
Hi, I work at a company. We're trying to standardize our new server-side API on Google Go. And unfortunately, the company's full of Ruby fanatics. And so we need some kind of migration strategy of how a software server written in Google Go can communicate with a software server written in Ruby. Looking at your RPC package, it looks like it's mostly made for Go code to talk to Go code. I mean, other than the REST API, is there any other solution for communicating across to another language?
I can recommend using JSON RPC if
Okay.
you're not comfortable using REST. So that'll JSON encode structures that you can send over HTTP.
Is there any other solution other than JSON as well?
You could use Basin. Serious response. Also, I think Ruby programmers tend to be pretty comfortable with the REST API. In my experience, Go's HTTP package gives you great facility for implementing and connecting to those. That would be the most natural thing, in my opinion. From what I've seen with Ruby programmers, a lot of our most sort of enthusiastic Go programmers in the open source community are ex-Ruby programmers. So I think, it's an easy sell for Rubyists sometimes.
Hello again. I think the thing that attracted me the most to using Go or learning more about it was the fact that it was the first language I saw that kind of explicitly acknowledged that the environment in which most modern software runs has changed considerably from traditional systems. And the concurrency packages and structures, I think, are probably the thing that attracts the most attention. I was wondering if you could just give us a little bit of insight into anything that might be upcoming in terms of concurrency structures and things that encourage more easily facilitated parallelism.
There's nothing actually planned. Go happened in part because someone asked me to give a talk about an old concurrent language I did at Google. That you can see it on YouTube, I think. And then I went back to my office and I tried to do it in C++ and it was too frustrating. So it sort of planted a seed. And it was only like within a year, I think, that we started talking about doing Go. One of the things that I'd like to see developed, it hasn't happened yet, and I played with it a little bit, is the ability to use these primitives across a network. Some people in the outside have developed some stuff. I wrote a package a few years ago, which I was never happy with, called NetChan, which is still around, but I don't recommend it. The guy at Tumblr, whose name I can't pronounce. He can pronounce it. I wrote a system called Ghost Circuit, I think, which he just open sourced, which lets you do some of that. And I think there's a lot to be done there. It's one place where, for example, Erlang does a beautiful job, and we don't do a job at all. I'd also like to see packages developed that are well, there's a bunch of patterns, like in Samir's talk, or in the talk I gave last year, where you see, fan in, fan out, multiplexing, load balancing, timeouts, aborts, cancellations. I think some of that could be librarified, but the language isn't strong enough to do it yet. And I would really like to see a way to make that nice. I think we may have, there's some new stuff in Go 1.1 about reflection on channels that makes it maybe possible to write those now, and it might be worth trying. But no actual plans.
Yeah, just to echo and expand on that, I think we're still discovering what you can do with Go with respect to concurrency. That as we gain more experience with how channels and select and Go routines fit together, patterns are evolving. They're showing up when we say, how do I do a send, but the receiver might have exited, and therefore I need to condition it in the right way. There's a lot of little things like this. You can think of it as like micro patterns in your code, which allow you to handle these funny cases and change the way you think about how your code is executing and how the different components are interacting.
Samir actually ran into my office the other day, all excited that he had found a new pattern in Go, and he wanted to describe it and give it a name. He went through and described it all, and was like, "Oh no, David did that months ago." And he's like, "Oh, bum."
It really is fun to find these things. Actually, the more you play with it, and the more you compose Go routines and have them communicate, you really do find some interesting ways to plug these things together. And we're still learning.
Great, thank you.
G'day again, back to the moderator. From Kyle Lemons, it has been said that post-Go 1.0, the Go team was spending more time writing apps and libraries in Go. Can you talk about your experiences with this? Have you discovered anything particularly surprising, fun, or problematic?
The garbage collector could use some work, but we actually have people working on the garbage collector now, so that's good.
And the runtime scheduler too. I mean, the general runtime, which includes the garbage collector, the scheduler, the implementation of channels and maps and all of that stuff, we knew, so it wasn't surprising, but it was problematic. it was really the weak point of the whole ecosystem. And most of the performance improvements that have come in the past year have been because of developments in that area, and there's a lot more to come. So that was interesting. We also found that the better the tools got, the better our understanding of the programs got, and therefore the more stuff we could see and fix or change. And we're still learning. The language in general is young enough that there really isn't a Go expert yet.
Kind of related to that, pre-Go 1.0, when we were still making changes to the language and to the standard libraries, Russ Cox made a tool called GoFix that you could run over source code. It would read the source code in, do some manipulation of the AST, and then write it back out again. And you know, that tool really kind of didn't have any use post Go 1 because at that point we stopped changing the language and libraries. But inside Google, we've found it really great for doing very large scale cleanups. The same kind of tooling translate great, so we can evolve our code inside Google that doesn't have that compatibility guarantee restriction on it, using the same tools. And it's great. We can clean up millions of lines of code very easily.
And GoFix is an example of a source transformation tool, and Go's libraries, mostly because of the work Robert done, has this ability to write amazing source transformation programs that pick your program up, make some change to it, write it back out again in a way that is not only safe but also neatly formatted and performant. And we're going to see more and more of those kind of tools. I think we barely scratched the surface on that.
As someone new to Go, you speak of micro patterns and things like that. Beyond just basic language documentation and API docs, where would you recommend to go to learn more idiomatic Go and Go patterns and things like that?
I would recommend if you go to talks.golang.org. There's, for instance, Samir's talk from today and David's and Rob's talk on concurrency patterns last year, and all those things are a great resource. The Go blog has a long history of articles that talk about all kinds of areas of Go idiom, and we intend to continue writing those articles. And reading the standard library is a great way to actually, a lot of it is extremely well documented internally. It's very clean, very readable, and a lot of people have told me that's how they got started learning Go, just by reading that stuff.
One of the recent changes, I don't know if I think it's been live for quite a while, but it's definitely part of Go 1.1, is that we've pushed a lot of examples into the documentation that are not only visible and tested when you build the package, but if you go to GoDoc, or at least at golang.org and look at the documents, the examples are actually executable right in the web browser. And so if you see an example that's close to what you want, you can play with it in the browser, modify it to do what you want, run it, check it, and all that, and then just grab that code and use it. And that's another good learning thing. And of course, you know about the tour. I assume tour at golang.org.
Okay. But yeah, we really want to improve all of this stuff. I mean, I think it's already pretty decent, particularly for a language as young as it is, but I certainly have a lot of ambition to broaden the scope of our documentation and really, try and share as much of our experience writing Go code as possible.
Cool, thanks.
Hey, so I kind of feel like a bastard for asking this, especially after I worked so hard on Go 1.1. But I've been noticing like a few inconsistencies across packages, which can of course only be fixed with introducing breaking changes. So I was wondering, are you already collecting stuff like that, and is Go 2.0 in your head even a thing right now?
We know lots of things we'd like to break, and we have a list of things somewhere on the issue tracker that we would fix, or at least think about fixing in Go 2. But Go 2 is not on the horizon in the sense that we're actively designing it, but we're definitely collecting a list of wouldn't it be nice to fix kind of things, some of which we've already mentioned.
Yeah, I mean, Go 2 exists so much as a category in which to throw issues that we can't fix today. But, as the general attitude is that we're not going to bother investing the time thinking about them or being frustrated by them because it's too far off on the horizon.
Thanks.
I wanted to find out if you have any plans, or I would like to see some influences from Erlang's OTP system. So it's not just the language, but the entire runtime system that has all kinds of hooks. So for example, if you have a channel that's blocked for a lot longer than you expect, then you have something like some profiling hook which says this is unexpected, or some debugging thing that says this is unexpected. So a set of tools that work along with the runtime. So another example is like in profiling, you just have the control plane currently. The statistics only show per Go routine how many things are called. But if you say, if I wanted to track a user request that logically transfers control through several Go routines and gets back a request, if I wanted to profile and say, where is this request taking time, where through its path through various Go routines, how can I sort of taint that particular stream of control that is not sort of, it's orthogonal to the Go routine, So I want some systemic hooks, basically.
We're very aware of all of those things and would love to see them. The tooling involved is interesting and work, and I don't mean that sarcastically. I mean, it's really interesting work. And some of the other systems at Google have pieces of that kind of thing that have not been adapted to Go yet, and I think would be nice to have. As far as the Erlang model, Erlang is a very different language. It's interpreted, functions are passable across the network. I think it does the stuff you're talking about beautifully, but Go is a different language. It's hard to see how to fit it in, but I would love to be proven wrong and have someone actually build that environment for Go. And it's entirely possible, but it's certainly not a priority for us at the moment. We just have a different model in mind.
Thanks. Take one.
Next moderator question. We might have touched this before, but Divox asks, has the Go team been putting any thoughts on how to provide more control over dependencies and imported packages? Not having a way to make sure everyone on the same team has the same version of third-party packages can be really painful.
Yeah, I think we've already discussed that.
Well, the thing we didn't discuss is if you're working with a big team or whatever, you could also just check in your dependencies to your own version control system. Then you can have a hermetic view of the world. You can sync back to like what the world looked like 2 weeks ago, and when you go to import it, or when you go to update a version of your dependencies, you update it, run all your tests. If all your tests pass, maybe you run it, you do performance tests on it, then you check it into your version control system. So, I mean, Go-Get is nice for, playing around, but if you're going to do something serious and you're actually going to deploy binaries to production, your deploy to production script shouldn't involve fetching some random dude's stuff on GitHub.
And I'm also not sure if it's really the role of the Go tool or the tooling provided by the language to actually dictate the way you manage your code in a production sense. One of the virtues of the Go tool is that it uses Git, Mercurial, Subversion, Bazaar, all tools that exist and that are well understood. And so if you need to build any tooling around them, you already understand those tools that you're already using. And so it should be relatively straightforward to integrate those with whatever system you have.
Next one from Carl Lemons again. Can you talk about the future of the runtime? How much of it could and or should be rewritten in Go?
Quite a bit of it could be rewritten in Go. The question also comes up, why isn't there a compiler written in Go? And the answer to both of those was, it got the way it is because of expediency. It was, to bootstrap. You can bootstrap the language while you're writing it in itself, but it's much more cost effective, especially when you're thinking of distributing it, once it's up and running, which was always a consideration for Go, to take an existing language and write in that, and C was an obvious candidate. So there's a compiler written in C. Ian's GCC Go is written in C++, uses the GCC backend. I think we have more and more of the pieces necessary to write the compiler in Go available. We've got the type checker now. There's an SSA package that can do a lot of the static analysis for good compilation. But there's no actual pressure on our side to do it. We don't think it needs to. As far as the runtime, more and more of it could be because the language is getting stronger and the efficiencies are coming. But again, we don't feel the pressure. There's no compelling reason to do it at the moment that I can see, but I could be wrong.
I agree.
I mean, one compelling reason could be that our Go compiler is actually better than our C compiler at this point in lots of things. So
that's not a compelling reason.
There's at least one project that's done outside, which I know of, which is using the existing libraries that we have for Go front end and is trying to hook this up with an LLVM backend. So, that's not a Go compiler entirely written in Go, but it's a step in that direction.
Well, I think we're out of time. We actually have some gifts for you that we'll be distributing from the left-hand side of the stage. But thank you all for coming. And and please take only one. Thank you.